Hello, everyone, and thank you for joining us. My name is Gisela, and I will be the host for today's webinar. Before I pass it over to our speakers, Cary and Philipp, let me cover a few housekeeping items. At the bottom of your screen, you will find multiple application engagement tools. You can adjust their size and position to optimize your computer screen. To expand your presentation area or maximize it to full screen, simply click to the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical questions located in the Help widget at the bottom of your screen. Please note that the copy of today's slide deck and additional resources are available in the resources list. Please have a look and download everything that you may find useful. Also, this webinar will be recorded and sent via the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We are here to answer you live via the chat throughout the presentation, so don't hesitate to reach out. In case we run out of time or we don't manage to answer your questions, we will make sure to follow up later by email. And with that, I will pass it over to our speaker, Cary.
Thanks, Gisela, for kicking us off. My name is Cary Bryczek. I'm the Director of Aerospace and Defense Solutions here at Jama. I'm really looking forward to speaking with you today on this particular topic and looking forward to Philipp's presentation as well. So to kind of kick things off, we are going to I just kind of want to set the stage with some trends across the A&D industry that we're seeing. I'll talk about how those trends are creating challenges for chief engineers and describe kind of what's keeping them up at night. Then I'll set the stage for Philipp's presentation by showing you what Jama Connect Traceable MBSE looks like and how that's designed to solve some of those challenges. And Philipp's going to definitely take you on a deeper dive to show you how system models and Jama Connect interoperate. In the aerospace and defense industry, developing a new system has complexity that far exceeds commercial product development. For example, the FAA's program to develop the unmanned aircraft traffic management system involves not just the pilot and his drone, but is designed to enable autonomous and semi-autonomous operation of multiple aerial systems, including passenger and cargo delivery, in a tightly integrated civil airspace. The elements in blue that you see are all distinct systems of their own, and the new traffic management system needs to be able to integrate communications and data across all of those systems to provide this new capability. In the highly constrained environment of outer space, NASA's Cislunar and the Artemis program, for examples, are focusing on the operation and survivability of autonomous systems. To develop a space system, NASA does not do this alone, but has many contracts with companies to deliver parts of the system. For example, Blue Origin, they have two programs like the friction stir additive manufacturing program and the metallic thermal protection system are two examples of just parts of the system. Canopy Aerospace, they're developing a low-cost reusable thermal protection system. Rocor, aka Redwire in Erie, Colorado, they're developing a characterization of high aspect ratio booms for these large apertures and so many more. This ecosystem of partners and contributing to a whole brings its own challenges to the fore when trying to collaborate, share data, and execute common systems engineering process. Like NASA's Cislunar and Artemis initiatives for space exploration, they're focusing on operation and survivability, right? In the defense domain, we're seeing all sorts of cases in unmanned aerial systems as well to aid tactical situations and help with strategic planning. Really, the underlying theme of these large systems is the integration and the collaborative approaches to developing these different weapon systems and aerospace systems in very constrained environments. So from a strategy perspective, what what are these agencies trying to really do? Government agencies and aerospace and defense companies are always evolving their strategies to be able to deal with this complexity and to help streamline their engineering processes. For example, the Department of Defense has published a new adaptive acquisition framework. This pathway is intended for large-scale traditional hardware acquisitions to facilitate rapid and iterative development and delivery of software capability to the user. In 2018, the digital engineering strategy outlines a vision to modernize how the department designs, develops, delivers, and operates, as well as sustains, right, systems securely and safely. And their vision is to connect people, process data, and the capabilities across an end-to-end digital enterprise. INCOSE published their recent Vision 2035 document, and it is intended to inspire and guide the strategic direction of systems engineering, the practice of systems engineering for the global systems community. MOSA, the modular open systems approach, it uses a system architecture that allows major subsystem components at the appropriate level, right, to be incrementally added, removed, replaced throughout the life cycle of the major system. The DoD's systems engineering and the architecture group is focusing on modernizing the systems engineering practice. They're leveraging capabilities from CERC. They're using MOSA to build systems that can be upgraded and to incorporate new technology faster to respond to emerging threats, right? When we look at this in a little bit larger view, with this new modernization of the systems engineering approach, the DoD has moved away from visualizing its process using a V model in favor of what truly takes place from a process standpoint, which is that modern systems engineering is highly cyclic in nature. You can see the outermost ring is as close to that old V model where concept definitions in the upper right, it moves to system definition through architecture and design and over to V&V and back to start around on the next cycle. What's important is that there's a strong emphasis on measuring, not just the system being built, but the process that's building the system, your systems engineering process, and that data and models are at the heart of it all. To the fullest extent, models should be used in favor of documents, and data should inform decision-making. So what is industry saying? There's a challenge to using data-driven approaches and models. The DoD has highlighted, there's a lack of an integrated approach to implementation of the systems engineering focus areas, and it's creating a delay in the full implementation of the digital transformation, which really is necessary to guide, necessary to ensure relevant guidance and skills, right? Continuing to use legacy tools and approaches is what is making integrated approaches not possible. What is necessary is to take a federated approach to data across the tool ecosystem and to use tools with more robust APIs, modern architectures that are standards-based, right? An MBSE approach requires an integrated approach to connect the system models, architecture, and requirements to the program teams and the software teams and the hardware teams. It doesn't mean to use a siloed system modeling tool and expect those teams to be able to consume and understand that model. In fact, what we hear quite often is, how do I achieve the benefits of MBSE when no other engineers can access model parameters that they need for downstream decisions?